Hi everyone, and welcome to the kubeadm office hours meeting of 4th of July. And yes, there are only, from what I think, European people here, because the US folks are on holiday. Today we're going to talk about the configuration changes we're about to do in kubeadm in 1.12. And I think I could just go ahead and share my screen, if that is okay by everyone, and we'll look a bit on the maybe on the KEP and on the PRs that have been merged and are about to be merged. Let's do that. Okay. So we have a tracking issue for this. I can open kubeadm office hours. Oh wait, let's say I'm here, and yes, here we have the issue. Thanks, Lubomir, for creating that one. The first thing we're going to do is remove version 1.1. That is done at head. So the first PR was this. I'm just going to quickly say what I did and why. So in the scheme, we register all the known API groups, both external and internal, so we can perform defaulting conversion and similar stuff. Removing the version 1.1 there. That was workaround for the fuzzing tests when we split up the struct that is not needed anymore. Don't claim we can perform config migrate when we have only one API. Start bumping from version 1.1 to version 1.2. In some places that are still didn't work. And now instead of, so earlier we had to support the case of type meta being unset, because we had a bug in when we marshaled the structs earlier, and we marshaled them without type meta. So hence when upgrading, we needed to fill in kind and API version automatically to the version 1.1 API. But we can now remove this hack and require type meta being set by default. So that means we can get rid of a lot of code here. And now if we try to detect the unsupported version in the beginning. So if we extract from the bytes, we extract the API version, and if it's a known old API version, we're going to say use kubeadm 1.11 to perform the conversion of this file, because kubeadm 1.11 can upgrade version 1.1 files to version 1.2. Then update the round trip unit test. So we have inside of config or util config, we have a unit test that reads various files. For example, here it read version 1.1 without type meta and made sure it's identical to the internal YAML here after conversion. And version 1.2 to internal, and the upgrade case where we read version 1.1, converted to internal, and wrote out this version 1.2, etc., etc. And we didn't need that. That was version 1.1 specific. So what do these look like? Here we have the version 1.1 spec that got then converted into version 1.2. And with this, with this we can get like the end-to-end flow of the configs, how they are actually used within. It's like an ET flow with the configs. And here we have a function for extracting API version and kind from YAML. So that's mostly it. This PR was the first one to merge yesterday, and it then stopped or like made kubeadm not use the version 1 alpha 1 API, but the PR to actually remove the version 1 alpha 1 folder. As can be seen here, it's only deletions. It's just an RM of the directory. Is here. And after this, we have, instead, we're adding version 1 alpha 3. And the plan is to, when version alpha, if we're confident in this version to be better on a better level, we can just rename this in the end of the cycle. We have to do it before code freeze. But if we are able to code it in a way that it supports all the features we need before, as described in the cap, before the code freeze, we can just rename. So that's good. And here, yeah, it's, as Tim said here, we need to do the bootstrap token to GA stuff. Definitely going to do that, but in a later PR. So what is needed to create a new API for kubeadm? First, just copy the version 1 alpha 2 directory into, and like with the version 1 alpha 3 package name. That is literally what I've done here. Do cp and rename all package names. After that, I'm starting to use version 1 alpha 3. So here, register in the scheme and prefer that version. Make the kubeadm config command recognize version 1 alpha 3 here. So it gets there. And when writing, write the new. And here, the run trip unit tests. Now kubeadm should support reading version 1 alpha 3. It should support reading version 1 alpha 2, converting to internal, marshalling as version 1 alpha 3, and the round trip of reading version 1 alpha 3 and going back should also work. So that's it, and the same for node config. And here is the exactly identical except version 1 alpha 3 there, spec that was added, and the same for the node configuration. Okay, so that is so far so good. Automated bump from version 1 alpha 2 references to version 1 alpha 3. So in order to make kubeadm use version 1 alpha 3 everywhere, I just did a find and replace everywhere. So this is like automated stuff. All references point to the new API. So that's that. That is how you can create a new API. One of the biggest changes for the new API is that we're gonna start doing different YAML documents instead of one big master configuration. So what it's gonna look like is something like this. Sample conf. See if we can refresh. Yes, there we go. So we want to have something. We want to split cluster and init configuration in two pieces. So one with really the cluster level configuration. Now master configuration is kind of a hybrid. It hosts the component configs. It hosts all the kubeadm init runtime, the execution level stuff, and it hosts the decide cluster state and everything. Now we want to split this into something more sane, and for that we're using key value here as well. We're using different YAML documents. So now we're going to have something like this, and this is only respected. It's not uploaded to the cluster config map. It's really local to the to what you're joining, or the master you're initializing. What else? Yeah, so the component config goes here. And as new component configs are available, we can just add support for them as separate YAML documents and not, or stop respecting. So like now we do extrags for the control plane components. Eventually we're going to be able to say here, kind kube API server configuration and API version kube API server config that case.io version 1 or beta 1. This is like 1.15 or something. So kind of a long way to go here still. But once this is available and we can use it, it's just a matter of a new YAML document. And if this then is specified, the extraargs is, we can say that the extraargs is not respected or something like that. And that will be the like migration plan. It should be that one.
Lucas, yeah. I'm not sure that the component config will replace all the flags.
No. Oh yeah, true.
So I think that at the end we will have both.
Yeah.
But let's see. It depends component by component.
Yeah, that is really a later question, but that is a really good point. But in the end, it's the important part is like we have this possibility, and then this is going to be, so everything but the init configuration is going to be uploaded to the cluster config map here, and these are also going into their own config maps, like kubelet 1.x. This is going to kubelet 1.x config map. This is going to the kube proxy config map, and these as they come along.
And Lucas, sorry, I asked in Slack, maybe you already answered me, but updates will fetch the kube proxy config map from the kube proxy component config from the kube proxy config map, which is the source of truth, or from the kubeadmin config map?
To be honest, I'm torn. And I would really like your input here. We could do either way. If we say that, hey, let's have every component have their own authoritative config map for their component config, I'm happy to do that.
I think that we can split this into steps. The first one is just use the monolithic kubeadmin config map with everything into, and then in a following PR we are removing from the kubeadmin config map the component config and use instead the authoritative sources.
Yeah, but do you think that many config maps with authoritative sources is better than duplicating?
I think that it is better to have only a unique source of truth.
Yes.
It is the real point. And since the many config map are what the component will use,
yeah,
that there is the risk that if we keep a copy, this copy gets outdated, and so it became nasty.
Yeah, I agree with you there, and I think it's I mean, I have like 5 PRs or so already for this, or maybe there's 6 in various. So yeah, it's a multiple step process because you can't make this change in one PR, obviously. But yeah, we should add that to the cap, that we want many alternative config maps instead of one monolith.
I will do it.
Okay, cool. There's just some replace. There's just some byte reordering. There's not much changing here either. So here is oh well, wait, let me go first to the stuff that's changing here in Marshall. Okay, so this is the main part of the PR. So we have a new function, split YAML documents, that takes a set of a byte slice. And the good thing here, with the new design, we can allow multiple. The initial step is like adding support for multiple config files being loaded. So you can load each YAML document from its own file, which means you can have, or you can like, however you want, but one or multiple files, or maybe a directory if we figure out how to do that. So we can have the init configuration in its own place, which is way better than now. Like if you wanna like share the configuration but still like have some master specific taints or whatever, it's getting really tricky. With this design, you can just have them in different files and source the generic config from one file and the master specific config from another. So it takes any set of bytes and returns a map between group, version, kind. This is a struct as it sounds, with the fields group, version, and kind, along with the YAML document itself. For that is split out. So here we create a buffer. We create a YAML reader from our Kubernetes util package. While we can read, say.
Sorry, Lucas. One question. If you can go back to the sample in Sublime. If I see well, you are the cluster configuration. Now yes. It is a separated first level object and not a nested object in init configuration.
Yes.
Okay, so this is a change with respect with the Google Doc.
Yes, I don't think I'm about to update the Google Doc, but I don't think I have that there yet. Right. Yeah, it's definitely a change. I think it makes sense this way. What do others think? Versus embedding cluster configuration inside of init configuration.
I think that I like it because for instance there will be, I guess, also an update configuration, configuration. And the updated configuration in this way can reuse the same cluster configuration.
Yeah.
So I think that I like in this way. I'm looking at it right now, but it's something interesting. I will point out it in the cap.
Cool. So basically, we read the YAML document until the like 3 these 3 bytes. And unmarshal those bytes, just unmarshal the type meta information, so we can know what group version and kind there is. And here we require kind and API version to be set for everything. And we also require the kind to be unique for all YAML documents, as discussed with Fabrizio. So that is that function. And then there's a helper or group version kinds from bytes. So give the function any bytes, and it will return what group version kinds there are in the different YAML documents. And also some more helpers. Group version kinds has a specific kind and has master or node configuration. And some unit tests for this is also in place to ensure the split YAML documents does what it should, and the other functions. So when we have this functionality, we can start using it in interesting ways. So here we also have another new function, any config file, and defaults to internal. So we have here is the thing, when we don't know if we're given an init or master configuration or node configuration, or like init or join configuration, we're just going to read it. We're going to see what group version kinds there are. And if it has master configuration, it's going to use the master configuration specific function to read it. And if it has node configuration, it's going to use the node config specific function. So this is like just some syntactic sugar. These have only been moved, so it's nothing special, and also a unit test added for detect unsupported version. Other than that, there's not much so the use case is here, for example. In one of the phases commands, we don't know if we're given a master or node configuration. We can just load it. We have it as a runtime object, which is the common interface between all possible, any possible Kubernetes API object. And then we switch on the type. So that's that here. And finally, in the follow-up here after that, we start to split the components configs out and actually do stuff with it. Okay, do I get the 3 commits now? It's no. Okay, so the next change, in order to split the component configuration code out, I'm gonna change the implementation specific here, but the idea is we only hold the component configs inside of the internal API, which is here. In API's kubeadm. They will only be stored here inside of this kind of help struct. Before they were in their own kind of non-standard structs that have been created just like that. So when the conversion code from version 1 alpha 2, when reading a version 1 alpha 2 file, it looked like this. So we have the external We have the old spec, transfer the information from here to here, now in the internal API there. And then when converting from the internal API to version 1 alpha 3 that has these removed, nothing's going to happen. Because in version 1 alpha 3, this was duplicated, but now we start to change it. We're removing these objects from the external API. So here we see that we don't have these anymore. And why I'm gonna explain in a moment. So for the validation is changing a little. Then some path renames, more path renames, some small other. But the most important thing is coming here soon. Okay, so the defaulting code has been moved into config, util config. The exact part can be still changed before I merge the PR, but the idea here is that we do the defaulting of the internal. The component configs are only stored in the internal API. We do the defaulting in set init dynamic defaults, as we do with other stuff as well. And here's the large change. So when we're unmarshalling from bytes to internal, we're gonna split the YAML document. First take the unseparate version, but we're gonna split the YAML document. Now we have a map of the group version, kind, and the file content. If we find a component config that we recognize from the kind, we're gonna decode it. We have a set of codecs here. We're gonna decode it into a pointer. And we're gonna, well, this is not that interesting, but just erase the type meta information from there for the unit tests. And if we find a master configuration kind, we're gonna use the normal flow using the kubeadm scheme codecs, marshal into internal configuration, and warn if it's ignored or if it's a kind we don't recognize. And then for every, and then we're going to apply the component config value we just loaded to the internal configuration. And to fully understand this, we need to look at the code here. This will change a bit. It's like work in progress, but the idea is we have a central place where we register what component configs we support. And here we support, for example, the kubeproxy configuration. We have a default value. We have some API versions we support. Now we support the internal and version 1 alpha 1 and conversion between them. And here is the part in the internal configuration.
Could you explain again the erase metadata bit?
The type meta. This.
Yes.
It's not that important, and I'm gonna see if I can just rework that a bit. It's just for the unit tests for the moment. So right now we in the internal API here there we embed the external APIs of the kubeproxy and the kubelets. I don't think we should do this. So, but as a consequence, we just need to erase the type meta information here when storing internally. But what I'm planning to do is to just use the internal version. So here as well. So that when we're using the internal version, say that the kube proxy creates a version 1 beta 1 API, then we can load either the alpha 1, version 1 alpha 1 that we use for legacy, or the version 1 beta 1. We can load both external bytes, and then when we decode, it's not gonna matter because both have conversions into the internal type.
Okay, so we are not going to embed the external component config API, but the internal, because we assume that this one is more stable.
So we're using the internal internally because then we can load any external version. Because we know that all external versions, whatever we load, have conversions to internal. And we can support multiple external versions by embedding the internal. Does that make sense?
Yes, that does it make sense. I have to write also this bit.
Yeah, this is like implementation details, but as I'm going to be able to write these ones, maybe the init configuration and cluster configuration split. It will depend on how fast we can get through the PRs and get approval and like how much time I have this week, but I'm hoping to get that done before I leave as well. But after that, so that's why I'm doing the knowledge sharing here, because we need to know why stuff is ordered in the way it's done. So I'm seeing erase type meta to go away, but here is like, and this I'm also thinking this will go away because this is what external group version we support now. Or no, this is going to be the write out group version. I'm going to clarify that. So what version is the newest one? So when we marshal the internal config, what should we convert the internal kube proxy configuration to, for example? Should we convert it to version 1 alpha 1 or version 1 beta 1? That kind of stuff.
This is something that is version related? No, because we are basically supporting the latest version.
Yes. So all this is really relevant to. We need to get this right, basically, to have an upgrade path forward. So, but I think this is going away. This points to what defaulting stuff to use. This just registers like get set from the internal config. So we can do it in a generic way without writing extra code for when we have 5 or more components configured we support. The same for the kubelets. Here we create a scheme. I'm gonna rework this bit, but we need to create a scheme first in order to support loading any component config. Add type meta. kubeadm scheme is actually not needed. I'm gonna remove that, and then run all add to scheme functions. So I can show what an add to scheme function looks like. This is the add to scheme function. So it basically exists in all in most registration files, and it basically adds the known API versions and or kinds. So if I'm looking up this specific bit for the kubelets, for example, I'm going package kubelet APIs version 1. Add known types. Add
scheme.
There. So
there is a package scheme.
Sorry?
There is a package called the schema. schema.
Yeah, that as well. But so I'm not sure this is an ideal way to do it. In other places like the kubeadm and the kubeproxy, we have scheme and codex as global variables, and I think that is way easier to use and creating, and probably more memory efficient as well. But that is, I'm gonna ask myself and why it's done like this. But here we have, in every API package, we have the add to scheme function. So it uses the scheme builder stuff to say that, hey, these are the kinds we support. And here are the structs, etc. That is the same in this register go file. We have add to scheme. So, and if we check the proxy component config, it's going to look pretty much the same. Kubelet proxy. So here we have a scheme package that releases all the stuff and has the global variables. And here we have the version specific. So in kubeadm, we can say that we explicitly support these versions of a specific component config. If that makes sense to you. So that is for let's see. That is for deserialization. We get get all the codecs that can convert and read any component config. We read them into value, and then we write the runtime object the value to the internal configuration using the supplied function. And what are we doing then when we have the internal configuration and we want to write it out to bytes? Well, in that case, we do this kind of thing. We get the codex again that can do anything with the component configs. We marshal the kubeadm internal kubeadm configuration using the specific group version. So this means if we specify an external group version here, like we're always going to do, like version 1 beta 1, it's first going to convert from the internal API to the external API, and then the component config information will get lost, and then write out the bytes. And that we store the bytes here in a byte-bytes array. And if we converted if we did a conversion to external and hence lost the component config information in that conversion, we should write the component config information out as separate YAML documents. So that is happening here. We get some defaulted component configs, or we get a defaulted master configuration object that is created like this. So we create a master configuration, we default it, we convert it to the internal, and we run set defaults proxy and kubelet configuration, basically. And there we have a default, what the default component configuration for the component looks like. And when we have some reference defaults, we can get here are the reference with the default internal configuration, and here is the component specific reference default configuration. And when we have that, we compare it to the actual component config we have that is going to be about to be written out. And I do this because if the component configuration that would be written out is equal to the default configuration, there is actually no need of writing it out, and it's only going to confuse more people if they see a lot of nubs when it's actually not needed.
I agree with this, but what is if I remember well, this part is in the config print default command.
Yes, all code is using these two functions.
Okay, so because in the config print default, I guess that we will never have the so the user will never see the component configuration. Does it make sense?
Yes, it does. But to fix that, I'm planning to add like so we have the API objects -- API objects, and when I'm just going to let that be. So the default list there is master configuration and node configuration, right? And I'm just going to extend that to one. So like now we support also kube proxy configuration and kubelet configuration, and the list defaults to all four. So when marshalling explicitly the master configuration, it's going to be only the master configuration YAML document. But we use the default API objects list, it's going to be all four, so we get all the information. Does that make sense?
It is more complicated than it should be, but let's see how it looks like after your work.
So I don't think that's more complicated than it should be, because then we also have the opportunity to print, like do kubeadm config print defaults -- API objects kube proxy configuration, and to get only the proxy configuration that is the default.
Okay, this is something interesting, because there are users that are could easily get a template configuration for the kubelet or for the kube proxy. So this is interesting.
Yeah, because the components aren't very good at exposing the defaults. So, but we can do it for them in kubeadm easily, and yeah, that is something we kind of have to do if we support reading and writing component config.
Sorry if I change the topic from the PR back to the CAP.
Yeah, I mean, I'm kind of.
I have only. I have to leave, so I just given a PSA. I'm starting to write the CAP at the beginning of the document. So if you or anyone can give a check, we are basically copy editing the CAP in a Google document, which is easier for the first pass.
Yes.
And basically the document is organized by macro topics, where for instance a macro topic is the kubelet config. So the component config, how we manage the component config. Another macro topic is how we manage booster token, and so on. In order to have for each macro topic the main use case and the implementation detail, because more or less every implementation detail is orthogonal to the others. Okay, so sorry, thank you, but I have to leave.
Okay, cool. I mean, I'm mostly done here. The only cool thing I can show last is like that now that we have the end-to-end unit tests, we can clearly see what the internal configuration will look like. It's pretty much the same, but we just change the names, kind of. I changed these by purpose to see that, so they're non-default. So when we convert them to version 1 alpha 3, it's not going to look like this, that we had it like it used to, embedding both kubelet and kubeproxy configuration. Instead, this is happening. And they are different YAML documents, API version kind, like that. So that is really neat, and it does the like round trip tests and all the stuff automatically. So we're now sure that kubeadm actually has this functionality.
Looks great, Lucas.
Cool.
Really a good job.
Thank you. If there aren't any questions, I think this walkthrough is kind of finished, and we're gonna do copy editing and more work on the KEP now that we have a clear path forward. I'm also gonna update or resolve the comments for the proposed API structure, but that is another topic for later. This was more how to do the initial refactor.
Great, thank you. Bye-bye.
Bye-bye.
And I'll probably have to go too in less than 10 minutes. So
yeah, I don't have anything more. So if nothing else, we'll just cancel this meeting. And I mean, we had a decent 45 minutes anyway. So
yeah, it was superb. Thank you for the walkthrough.
Great. See ya.
See ya. Bye bye.